Questions on the homework?
What homework do we have?
6.1 and 6.2 worksheet.
When was that?
Huh?
When was that?
Yesterday.
Oh, we have something here.
Yeah, that's type skip.
We had chairs.
She decided to skip. And Abby. Guys, y'all better get ready to pay attention to you today. I can't talk. Y'all better get ready to pay attention today. I'll be calling out.
Yeah, he was calling out yesterday. What are you talking about calling out? He was like,
We all weren't here yesterday?
If I answer, my thing is if I'm able to answer 3 in a row, somebody answer the next one.
answer what we do.
Answer questions that we go through.
Oh my god, that's
Answer 3 in a row, somebody's answering. That's what it's about. Now.
Lounge all the way down. Yeah. One review sheet. So,
Are we doing log?
we're doing logarithms. LOG. So,
Oh my gosh. This is hard.
Is it hard?
No.
Yes, it is.
I don't know. He doesn't write stuff down.
Reed needed. Wait.
Okay.
Reed Williams needed help on this.
Mr. McClin, is that true?
because it's not going to be as difficult as whatever he's doing, but no, because what we're looking at today is log base b of y equals x, if and only if b to the x is equal to y. So log base b of x, make sure I'm getting because I want this set up to be the way the y equals x, if and only if b to the x is equal to y. Log base b of x, log base b of y equals x, if and only if b to the x equals y. So we have these two forms. Our LOG is our logarithmic form. B to the x is our exponential. And we have this here where b is different than 1. And we have this here. Now, the first thing we're going to do with logarithms is we're going to rewrite it from logarithmic form. So our log base b of y equals x. And we're going to rewrite it in exponential form. B to the x is equal to y. So we're not going to have to do this on all of them, but I want to do this on the first few. There is not, okay. Yeah, my computer has not been wanting to print every now and then. You can.
Okay.
Well, I'll pull up my download folder. It is one above the, yep. Yeah, because one. Yep. I think it's the computer's slowly dying. All right, guys.
I know what they are.
B. B would be 2.
X is 4.
X is 4.
Y is 16.
Okay. Questions on how we found the value b, x, and y? So again, our b, x, and y, where we got them was from log base b of y equals x. So b is 2, y is 16, x is 4. We good with that there. Now the exponential version of this that it's equivalent to is b to the x is equal to y. So for us here, the value of b is 2, our x is 4. 2 to the 4th is 16.
It gets harder to count the row. Did Reed not come in and ask for help on one of these questions?
I think so. It's been a while.
We all struggled. Maybe we forgot what he was doing.
I think it was one of the more complex.
I mean, with everything in mathematics, we do build up to something. But this here, we're just working on going from logarithmic to exponential, going from one to the other.
This is level 1.
Why does it get all the way up?
Bx and y.
4, 0, 1.
So b would be 4. Our x would be 0. Y would be 1.
I'm writing it down. I can't see you write at the same time.
I'm doing it. You can do it.
We have
Yes.
different brains.
For
the Y design stuff that way.
this is, so part of it's dealing with inverses, inverse functions. Now, for the main logarithmic, or not logarithmic, but exponential form of this here, we're looking at 10 to the x, which is this function here. So that's our exponential. Now, our normal logarithmic function is this here, log of x. And they are inverses of each other. We can go from one to the other because it's a different type operation, but they are inverses. And the main way we can determine if two functions are inverses is if they are a reciprocal or flipped over this line y equals x. So they're an inverse of each other. So instead of going through the full process of inverses, because we haven't quite gotten there exactly how to do it, when we do, we'll get back to it. We'll come back across it. But there is a way and method to go from one to the other. We just haven't got there yet because I don't want to just throw that in also. Because there is ways to apply the properties of logs to our b to the x equals y to get it into that form, to go from one to the other. But the main thing we're going to focus on now is just how they line up.
Okay.
So our b and b, x and x, y and y. So this one, if we turn log base 4 of 1 equals 0 into an exponential, it would be
4 equals 0.
4 to the 0 equals 1.
So why do we have to add 0?
Because if we don't put a number there, it's understood to be 1. So 0 we have to put. And for all these here, even if it is understood for this part, we're going to write it in. Because here we're just making sure we see how it transfers from one to the other. And the nice part with both of these here, 2 to the 4th. Well, I can grab a calculator and say 2 to the 4th power is 16. So that was set up correctly. The one we just did was 4 to the 0 power is 1. Anything to the 0 power is 1. There's only one exception, and that is 0. We can't have 0 to the 0 power. But that's it there. Questions on this here? Our next one, we have log base 12 of 12 equals 1.
12. B, 12.
B is
X
12,
equals 1.
X
Y.
is
Or not. X
1, 12.
Y.
So our base is indeed 12. Our x is 1, and our y is 12. So our b to the x equals y. Well, b is
12 to the first equals 12.
to the first is equal to 12. Questions on this here? Now, we don't always have to write out the b, x, and y. If that helps to keep it straight, keep it organized, do that. But even if we didn't write it, our base for this is what? 1/4. And this would be 2. Negative 1
Negative first.
is equal to 4.
I need to get this right. X. Y.
Then comes one page. Yeah, one was 2 pages. You're good? Two-sided or one-sided? Yeah, they're the same thing. It's just it means nothing's printed on one side. So that's two-sided there, so front and back. You're welcome. Questions on this here? Because 12 to the first, we can see, because here 1/4 to the negative 1 is indeed 4.
Does it matter if it's parentheses?
It doesn't. I like putting the parentheses around it just so that we can keep the terms together. Now, I did redo the note sheet so that y'all have a little more space than this, because mine are a little more clumped together. Let's look at A. Log base 6 of 216 is equal to 3.
Where's this? Bro,
Yep, y'all's are a little more spaced out.
6 to the third equals 265.
So 6 to the third power is 216. How about the next one?
7 to the 0 power.
Oh, sorry, I'm on the wrong one.
7 to the 0 power is equal to 1. Come on, Kirsten, do the next one.
21 to the first equals 21. That's not Kirsten. Is your name Kirsten?
Okay, Kirsten.
Okay, Kirsten.
Okay, Kirsten.
I didn't hear Kirsten's name. I was in a rush.
You're closest to him. Bro.
Oh, wait. You said it?
Yes.
I thought one of y'all said it.
Okay, Kaden. Your turn.
So the last one,
What is
Kirsten?
negative 1?
1/5 to the negative 1 equals.
Okay, Kirsten. Or Kaden.
Keep hearing my name. I'm getting confused.
Questions?
Got him. I got this down.
So we feel comfortable with these here, yes? All right. Now we're going to go the other way around.
Yay.
Now they give us the exponential form.
Oh, it's just reversing.
So they're giving us b to the x equals y. And we want to change it to logarithmic.
5
It'd be log 5 of 25.
log 5 yeah.
Equals 2.
Equals 2, baby. Come on now.
Yes.
Stop playing with us.
Because our b value in this case is 5, x is 2, y is 25. So here, log base 5 of 25 is equal to 2. Now, we don't necessarily need the parentheses, but sometimes it's nice to have them just to keep these separated. And that's it. One thing I will say is make sure the 5, our base, is a little bit lower, because we don't want to write this
As log 5.
log 5 25 equals,
It is 5 times 25.
that's what it's going to appear. Because if there's no base written, and we'll get to it, and it's what we call common logs, the base is understood to be 10. So if no base is written here, it's understood to be 10. And we'll get into those, and that's also, if you notice on the calculator that there is a log button, this is the common log. So its base is 10. So we can't just type these in if the base is something other than 10. Now, is there a way to plug that in? With the base of 5, yes. We have to use something called change of base, change the base to 10, but we'll get there eventually. How about we look at the next one?
It'd be log base 10, 0.1 equals negative 10.
Log base 10 of 0.1 is negative 1.
Oh, I got that right. Yeah, buddy. Sure.
Questions on A or B? Let's look at C. 8 to the 2/3 equals 4. Log base 8
And then 4 equals 2.
So for C, log base 8 of 4 equals 2/3. Questions on how we got this here? Okay. Let's look at the next one. 6 to the negative 3 equals 1 over 2/16.
Log base 6 of 1 over 2 and 16.
Our base 6.
Negative 3. Did I get that right? Let's go.
Yes.
Alright, Abby. Next one's your turn.
Yeah, we all got to wait. Hey, wait.
Let's go, Abby.
I went.
I'm not in on
It's
this.
not hard.
I know.
Like work, Abby.
9 squared equals 81. We need to go back.
No, I got it.
9 squared equals 81.
Base 9.
Log base 9 of
81.
81
Equals 2.
equals 2. Yes.
Good job, Abby.
All right, now Kirsten. Write down the last. Okay, wait.
Dr. Shannon's turn.
Wait, let me write this down.
Okay.
I know how to do it.
Just kidding.
Okay, wait, which one are we doing?
B.
Okay. Log, and then you got 20, and then your 0.05, and then your -5.
Yep. Log base 20 of 0.05 equals -1.
Log 16.
Log base 16 of,
I can't see it. Of 8.
yes,
Yes,
8
sir.
equals
3/4.
3/4.
Good job. You want to go? Kaden, you want to go? I want to see Jackson.
Okay, Jackson.
Jackson. Yeah, Jackson.
Yeah.
Log 15. Parentheses 1/200
Okay.
And it was
equals -2.
Yes. Log base 15 of 100 over 225 equals -2. And that's it.
he brought
Yo, Jackson, take the test right now.
Questions on this here? We're ready for the next part.
Yes.
So there are 2 things that y'all need to add. You can either add it, you can add it at the bottom of the page. But this here is good to know. Log base B of 1 is 0, no matter what the base is. As long as the base is not 0. We can't have 0 to the 0. The log base B of 1 is 0. And the reason for that is if we wrote log base B of 1 as an exponential, rewrite in exponential form, we just get B to the 0 equals 1. So if what's inside the logarithm is 1, it's going to equal 0.
Yeah.
Our other one that's nice to know is when the base and what's inside are the same, it equals 1. Because if we wrote log base B of B in exponential form, it's just B to the first equals B. And when we start solving and working these here, these are going to be very helpful to know, especially log base B of B simplifying to 1. And when we get our other properties, this is going to be helpful.
Oh no, not again.
You don't understand, Houston? The amount of good people we have left are like 3.
I'm in there, right?
No.
Duh.
Ooh, you're not talking about yourself.
That's crazy. I'm definitely talking about myself.
All right, guys. Log base 4 of 64. We want to evaluate, we want to see what this equals. Since we don't know what it equals, we'll set it equal to x. And I'm going to rewrite it in exponential form. So this, in exponential form, would be
4
to the
x
is equal to. So we really want to determine what value or what power x is that would make 4 into 64.
I'm gonna say 8. I'm gonna say 4. I'm gonna say 4. It's not 8. No, not 8. Oh my god. Yeah. Dang.
2.
2?
See, oh.
No, 3. She's gonna be cubed.
It's gonna be 2/3.
Final answer. Oh, let's go.
I lied.
So
I forgot to do
Good
it.
job, dude.
So x is 3. Another way we could say this is because 64 is 4 to the, and we will have this property come up later. It's something called the 1-to-1 property, 1-to-1. Well, since both of the bases are 4, the exponents also have to be the same. Because if the bases are the same, we can set the exponents equal to each other. So x is equal to 3.
This man is recording. Can I have a math?
5x, 5
5 to the x,
equals
0.2. Now, if we could do like we did on the last one, get them both be 4, or here both be 5, that'd make this a little bit nicer, yes?
Yeah.
Well,
This has to be a decimal.
well, let's convert the decimal to a fraction. So, 0.2 is 1/5. So that makes it a little bit easier to work with. So if we get decimals for problems like this here, we can convert it to fraction form. And yes, both of them are 5, yes? Now it'd be nice if we could move that 5 out of the denominator to the
It has to be -5.
numerator. So we can move it to the top, but we wouldn't make the 5 negative. We would make it,
Denominator. Oh, it's exponent. Oh my god.
because we did this yesterday with our exponents, because when we talked about e to the -6x, we can move it from the top to the bottom, and the exponent goes from positive to negative. Or it goes from negative to positive. So positive to negative, or negative to positive. But the reason that this is nice is because now both of the bases are 5. They're the same. So the exponents have to be the, so here we're saying x is
That makes sense. That
so we
makes
say
sense.
5 to the -1 is
Say that.
1/5.
I'm gonna die.
Questions on this here?
Go call it a hole.
Is this the first time you've ever actually cringed at your subject?
Bro, I cringe at myself like 9 times a day. I do it every day. Nah.
Where is that one? It's next. Oh. Oh, I lied. Yeah. No, I was right. No, you're right.
Log base 1/5 of 125.
5x equals 1/2. Yes. Well, 1/5.
1/5.
And
I don't know. Why did I say 5?
x equals 1/5.
We don't know, guys. We don't know.
No, I don't know. Just
Wait, that's not C.
Did I flip C and D? Yeah, I think I flipped them by accident. Yep. Now, kind of like what we did on the last one, we want to try to get these to be the same. So our 1/5, well, like the last one, we can move the 5 to the numerator, making its exponent be -1. 125, it'd be nice if we could write it as 5 to a power. So what do we think?
3.
5 to the third
Yep.
is 125.
We do it. We're a team.
some are off, I think.
Yeah,
Is that the one in here?
Yeah.
that's the hallway.
Take someone off.
Powers of powers. Multiply.
Your column is from center.
Yeah.
Have you guys ever noticed every single year they're trying to fix the speakers?
Literally.
Yep.
Then they change the bell.
Yeah.
I had it over the oh crap.
They worked on it all of the summer, like all of the summer.
Obviously not.
It's a lot of work.
Well, the speakers were working at the start of the year, but I think
I
it's
feel like towards the end of the year last year too.
Actually, so
Not
Yeah.
the old bell. Yeah,
Okay. Questions on what we got to this here?
Wait.
To solve for x, we can multiply or divide by -1, telling us x is -3. Let's look at the last one in this set of 4. Log base 36 of 6 equals what? So as an exponential, it would be what?
36.
To the equals 36 to the x equals 6. 36 to the x is equal to 6. Now this one here, again, we've been trying to get them to be the same. Well, we have 36 and 6, and up to this point, we've been mainly changing the number that didn't have the variable. But here it's going to be easier to change 36 than it is to change 6. Because really here we have 6 to the first. That'll come into play in a minute. But 6 times itself, how many times is 36?
3 times. 2
5.
times. 6 times.
5, 10, 5.
5.
No, it's not 5.
Times itself.
It's 6.
Duh. No, it's 3.
5 times.
Not 3.
That's 5 times.
It's 2. It's 2. Oh my god.
Because 6 squared is 36. Now our powers of powers.
6 times 6, 36.
So 6 squared to the x. Powers of powers multiply, so our 2 times x. So this is telling us what? That 2x is equal to 1. Solve this here, we would.
Subtract 2 from this one. Or divide.
Divide. Telling us x is 1/2, 1/2. Questions on this here? Questions on anything we've done so far?
Let's do another one like that. You lost me after x minus or x negative.
What?
What?
We nailed it. I mean, not.
Now, log base 4 of 256. Now we've said with both of these here, the log button itself, so here, log is to the base 10. So we can't just use log of 64 because that gives us a decimal. But hit math.
Wait, what?
So turn it on and then hit math.
What about log?
So we'll get there.
Delete log base.
Yes. If you scroll down, there's one option called log base. And if we hit enter, we have this here. So our log, so we have log of 4 of 256. Log of 4 of
Oh.
256. So we hit math, then scroll up or down to log base and hit enter.
What row? What row?
So we can just be doing that instead.
What row?
So it's 4.
Do we have to do that every time? Wait, we could have done that the whole time?
For these last set, yeah. Because we can reselect it and say 8 of 0.125.
Do we put x equals? -1. Or just put 1. Okay.
Well, we wouldn't just put 1. We put
X equals negative.
-1.
Oh, just negative one.
Are we
Yeah.
supposed to what? What do we do?
So
How do we do a fraction?
C. So we can go math, log base. So our base this time is 1/3. So to get a fraction, we do alpha, y equals, enter, 1/3.
Click an alpha and
What? It clicked. It made a Y.
Alpha, y equals,
I clicked an
No,
alpha.
I didn't even know.
so alpha, then y equals,
Okay, alpha, y equals fraction. What the
enter.
Kirsten.
Yeah, it didn't work for me either.
Here,
I know.
alpha,
So alpha,
enter, and then we go whatever, 1, 1/3. I'm just showing you.
Maybe I like accidentally pressed.
No, you weren't on the cube thing, and you were just on
No one's doing the real problem.
27,
I don't know what to do.
Oh, wow.
-3.
-3.
Let me show you.
It takes Y. Getting mad.
Here, I got you, I got you.
I'm just gonna show
I
her.
got you, big dog. Big dog. Go ahead, what's your number? Ready? Y.
Exactly. It
Aw.
turns into a Y.
Aw.
What is? Why is it only the one that turns into a Y?
So then go alpha,
I was like, where does your friend go? But he's standing right behind me.
and then you're gonna push random number, whatever you need.
Yeah.
Yeah. So do it again. So for the last one. So math,
Okay.
alpha.
On this? Right
Yep.
here?
So just right there, you can go alpha, y equals,
Oh. Oh. Okay, that's fine.
enter.
Row.
Yep. Yeah, because the y equals button lets us do fractions. The other option we could do is, well, because really what is a fraction? A fraction is just dividing, yes? So we could also do division, 1 divided by 3, because that's all a fraction is. And the last one,
That one is 0.5.
Yeah, let's go.
Yeah, buddy.
Wait, we all suck.
Oh.
0.5 or 1/2. If we get a number that's not a nice decimal, it's going to be, I would prefer that you put it as a fraction. So if we did log base 64 of 4, math, enter, enter, we can convert it to a fraction. Questions on this here? Are you ready for the next part?
Oh, I'm trying to catch it, Dad.
We also have natural logs, natural logarithms.
Logarithm?
Now, the abbreviation for the natural log is
Ln.
LN.
ln
LN.
of x equals y only if e of
If
y
and only if
equals
E.
x.
To the y equals x. So the natural log of x equals y if and only if e to the y is equal to x. Now with natural logs, the base here is understood to be e. We don't have to write it in for natural logs. Because unlike our other logarithms, the base for natural logs is always e. It will never change. It's always e.
Is there a thingy for this that we could do besides what we're doing?
So here, we're just rewriting them. So our ln of x equals y if and only if e to the y is equal to x.
Abby, just tell me what was it.
Ln of x equals y if and only if e to the y is equal to x. Now here, our x is,
6.
and the y is
X.
x. And our base this time is e. So we're writing it as an exponential form. So e to the what?
Oh, 6.
E to the what? X.
X.
Equals
6.
6.
You and I want
All right, guys, let's focus in. Our next one, we have the natural log of 5a equals b. Well, our x in this case is 5a. Our y is
B.
So in our exponential form, we would have e to our y, so e to the
B.
equals
5A.
5a. And that's it.
Why is there an E now?
Because the base for the natural log is understood to be e. Mm-hmm.
Log of E.
Yeah. And e is an irrational number. Questions on any of this here? Let's look at two more. ln of 42 equals b.
X is 42, Y is
So x would be our 42. Y would be our b. So e to the b
42.
equals 42. And the last one that we're going to do today. We would have e to the
6 equals
Z.
e to the 6
6.
is equal to
Z.
z.
Like, wait.
So that was our last one.
That's the last one we'll do today. We're going to finish this up tomorrow.